Welcome back to the Glacial Gold Hunter. As you can see, it's winter. The creeks are frozen, the gravel bars are frozen, and if I go out there, I'll be frozen. So today we're going to be doing some hard rock mining. Over the summer, I've been collecting quartz from some of my higher production gold-bearing spots. In theory, this is where the gold originated from, these quartz veins. So what I'm going to do is I'm going to pulverize these into powder and pan this out just like they do in a hard rock mine. We're going to see if it's possible to extract gold from hard rock found in Wisconsin. Now I want to be super careful to avoid any contamination, so before I do this I'm going to wash each one of these rocks because there's a chance that there's a bit of clay or mud residue and there might be some gold sticking to it that didn't come from inside. But first I'm going to show you something really cool about quartz. If you take two pieces and rub it together, like that, watch what it looks like in the dark. It sparks. It's called triboluminescence. The quartz crystals have a positive and negative charge on each end, and when you break them and rub them together, it creates little lightning bolts inside. Geology is cool. Alright, let's wash them. Add some jet dry. I got my brush. Start scrubbing. I got a lot to get through. Alright, so I got a whole pile of quartz here, all scrubbed up clean. I should pan this out and see if there's anything we scrubbed off. Now with a lot of this quartz here, I'm sure there's nothing in it. A lot of it is this pure white quartz, and that's not really what you want. I believe Jeff Williams calls this bull quartz. But there are a lot of pieces of quartz that are dark, stained, kind of reddish, and that shows indication of oxidation. That can carry minerals with it. That could mean that there's sulfides or other metallic minerals that have come with the quartz. Now it's possible that there's some mineralization along with the white quartz. It won't be high grade, but there might be something in there. So I got to check that too because I don't know which pieces may or may not have anything in there. I'm just going to crush it all up. Now this is actual high grade ore. Believe it or not, years ago I used to work in an underground gold mine. I worked in the Midas mine of Nevada. This is a piece that I rescued while I worked there. Carried it out in my lunchbox. We followed the vein structure, which was primarily quartz and calcite, and we would see these strings of mineralization. You can see this black bar here. That's primarily silver ore. Now there's gold in with this, but it's not visible to the naked eye. I never did see visible gold, but high grade would run about 200 ounces per ton of silver and 1 ounce per ton of gold. Newmont was after the gold, so the silver was basically a byproduct to them. Now there's nothing that looks like this in my samples. And realistically, this mineralization would probably get crushed up a lot easier in the glaciers than a pure piece of quartz. Now I surely don't think I have the mother lode here, but it's an experiment to see if there's any gold present at all in the quartz that we find in our tailings. So let's get to the hard part and start crushing this up. That's going to take some time. First, I want to pan this out. I washed all those little pieces off that quartz. That's a lot more than I thought there'd be. I mean, they're super small. There's a penny for scale. Well, I did my best to clean that off, so hopefully we can see something definitive by the time we're done with this. I should mention I only worked in the gold mine for one drilling season. Most of my geologic career I've worked in the oil industry and geotechnical engineering, which isn't nearly as cool as mining, but I didn't really care for Nevada. So I'm not exactly an expert in economic geology. I know the basics, but the details get pretty tricky. I know enough to know there's a whole lot I don't know. I know I'm not going to grind this up. I rescued it. 23 pounds of ore. If this big thing is actually quartz, 37 pounds of ore. Still gotta break that open and see what it is. So to crush this, we're gonna use our rock crusher that we built. Made a video about that you can check out if you want. I was given the advice that I should roast this ore in a bonfire to help it break up, so it would break up easier. So I wrapped a few pieces in wire and threw it in my wood stove. And I can see the heat of the fire did crack some of it already, and some of it oxidized a little bit more. It turned it a little bit more red, and that kind of gives me hope that there might be some metallic minerals in there, not just quartz. I threw this big one in there too, and I can see it fractured all along there, so that's gonna be a heap lot easier to break open. But we gotta see if this is actually quartz or quartzite. Gotta break it. So that is indeed a giant piece of quartz, and I can see some sulfides in there. That's a really good sign. Big spot of iron staining there, probably from oxidized sulfides, and I can see some crystalline sulfides right there. So maybe iron pyrite, maybe chalcopyrite. Chalcopyrite is a copper iron sulfide. So yeah, that big piece will be worth crushing down. Let's crush it all up. I built this bigger one here so I can put big pieces like this in there. That's a lot bigger than the ones you can get on Amazon. This thing is gonna be loud, so I got my earmuffs. And silica dust is particularly bad, and this is going to be pumping dust up into the air, so I'm going to wear a respirator because I don't want emphysema.
I'm your father, Luke. Give in to the dark side of the Force, you knob.
He saw Jedi 17 times, eh?
Now I tried crunching up some of the non-roasted ones, so now I'm going to try the roasted ones, see if that's easier. The roasted ones definitely break up easier. Now I'm not able to get the rock to go to a fine powder because the dust starts to build up and it kind of protects some of those rock grains. So I'm going to have to go through this a couple times. I get it to a point like this where there's a mix of very fine powder and like gravel sized pieces. I'll sift out the fine powder and then rerun the gravel sized pieces, and hopefully each time it gets smaller and smaller. Really hope there's something to see at the end of this. It's a lot of work. Alright, we crushed all that up, and you can see there's a lot of big gravel sized pieces, but there's some fine usable powder. So we're going to screen that out and do it all over again. Look at that. That is some fine quartz powder right there. That's a lot of gravel to go through again. It looks just like rock salt, and there's a surefire way to tell. Nope, it's quartz. So I went through all of it again. It's a little bit finer now, but the smaller it gets, the harder it gets to pulverize it, because that powder makes a spatial layer there, and it can't get like contact between the hammer and the steel plate to actually crush it. It just floats in there. So the cost is kind of outweighing the benefit at this point. But I'll save this and see what we got left. So I got probably equal amounts of pulverized quartz to quartz gravel, but it's getting increasingly harder to pulverize that. I mean, one piece is easier to crunch, but you know, strength in numbers. I'm going to classify what I have here. I just remembered I didn't clean this. I'm going to go scrub this clean, and then I'm going to classify this gravel. Maybe run the bigger pieces one more time. I'll try to figure out the next step. Alright, that's been scrubbed clean, so no contaminant should come from this. So I've got just a few pieces that are above 1/4 inch. I'm going to run through those one more time, and then my smaller ones, I'm going to roast those and try a mortar and pestle. Now, what some of you don't know is I'm an amateur bronzesmith. I have a second channel called Lundgren Bronze Studios where I make bronze sculptures. So I'm going to use one of my crucibles to take care of some of this stubborn quartz. I'm going to fill a crucible and roast it. Should have done that with all the quartz to start with probably, but this is all experimentation. Let's see how this works. I'm not looking to melt that at all. If I melted that, it's going to be a big block of messy glass. Can't get any gold out of that. I'm just trying to heat it up so the quartz is more brittle and it'll shatter apart. And when I compare the color to what I didn't roast versus what I did roast, this roasted is a little bit more red, and there's some pieces in there that are a lot more oxidized. So those pieces probably have a better chance of having some mineralization. It's not a huge color change though. You can barely tell. So experimenting between the pieces I just heated and the pieces I quenched, there's a big difference. The pieces that I quenched, they fracture way easier. So that thermal shock really does something to break up that crystal structure. Next time I do this, if there is a next time, I'm going to roast some big chunks of quartz and dunk them in water to get that thermal shock before I even start crushing them. But that's the point of doing an experiment like this. You learn a lot of things you didn't know you needed to know. So the last thing I'm going to try is this little thing here. Mortar and pestle. Let's see how this goes. We all pick in which ways we want to waste time from time to time. I mean, it works. It's not fast, but it works. When it stops being fun, I'll stop doing it.
That reminds me, I wanted to talk about safety goggles.
I think it's done being fun. I'm done. Alright, so I weighed what we got, and there's 17 pounds here. So almost half of what we had, we've got in the usable powder. If there's gold in here, maybe I'll do the rest at another time. But for now, I'm going to go with this. But the question is, do I pan this out or use my cleanup sluice? I think I'm going to go the cleanup sluice route. But first, I'm going to make sure that there's no gold hiding inside. So I'm going to clean it out really well. Those are the specks that were stuck in the sluice. Alright, now I've worked really hard to try to mitigate any contamination from any past cleanups, so hopefully any gold we see, we know it came from inside the rock. I'm going to take this nice and slow. Let's start running. I'm a little bit nervous about putting dry material into the water, so I'm going to wet this down and then scoop it. How many tablespoons of sand is 17 pounds worth? It's a lot. It's a lot of spoonfuls. Now the water's getting kind of murky, but it does look like there's some specks of gold sitting in those top riffles already. I think my battery's dying though. I keep having to turn it up a bit. I'm going to look at what's in the sluice, but I think we're going to pan the rest. This pan has been scrubbed clean, so there shouldn't be any contaminants there either. I think panning is going to be quicker to go through this anyway. Cleanup sluice really isn't made for that much material. So I pan down the 17 pounds, and after each pan, I've been putting it in this little dish. So this is our concentrates. So now is the final reveal. And here's what we got. 17 pounds panned down into a little tiny pile of sulfides. Now it's dark and it's heavy. I see some golden colored specks in there, but sulfides are golden colored too. They're so tiny. They're so tiny I don't know that I'd be able to test if they're gold or sulfides. You can see it's definitely a golden color, but not quite the luster of gold. Depending on the lighting, it can look gold or it can kind of look black. But gold always looks gold. So I'm going to take a magnet and see if there's any magnetite that I can separate from this. So the magnets worked really well and left behind that golden color sulfides. Now there are a couple pieces that look a little bit brighter that may be gold, but this is so tiny I just can't tell. When I worked in the mines, we would take our samples and put it under the microscope, and they said if you see something like visible gold, you take a pin and try to squish it. Gold is malleable, sulfides will break. I never saw visible gold while I was there, and this is just too small to test that way. Now to me, this is just fascinating. Is it worth it to crush up pieces of quartz like this? Probably not. Not unless you're just trying to do a science experiment like I did. But if you see stuff like this with actual mineralization, maybe. My guess is that the pieces that survived riding down the glaciers are just that hard, pure quartz. If they had a lot of mineralization, it's going to be a more fragile type of vein structure, and it's going to break up along the way. That would be my guess, but I'm not entirely sure. I'm going to save this in its own vial in case I want to look at it at a future date, but as far as gold today, we didn't do too well. Still, this is a fascinating experiment to me. I hope you enjoyed it. Thanks for watching. Come on back for the next adventure. Bye-bye. So update on the vial. I've left it in the solution for a while, and it's actually starting to oxidize and darken. But there are some specks in there that seem to be remaining golden color. So I actually do think there were a few very, very small specks of gold in there. So maybe we weren't totally off base. Still a trace amount, but there's your update.